Hello, I'm the awesome tutor, and today we're going to be looking at titration calculations. Now in this video I will be assuming that you know what a titration is and how to carry out a titration experiment. I'm just going to give an overview of it. Titration is a method for measuring the volumes of two solutions that react together. And in this case we're going to be using the solutions of acids and alkali. And this reaction is called a neutralization reaction. And we can use the results from a titration experiment to work out the concentration of the unknown solution. And that is what we're going to do today, titration calculations. Okay, so before we go to the questions, we have to know the basics. To calculate concentration in a titration calculation, we divide the number of moles by the volume. Here's this little handy triangle which you can use. Concentration multiplied by volume is going to give you the mole number. Concentration is mole over volume. Volume is moles over concentration. If you need help remembering this, if you know that the concentration unit is moles per decimeter cubed, moles divided by decimeter cubed, moles divided by the volume, then you should remember this equation. So concentration, moles per decimeter cubed. Moles, mole. Decimeter cubed, volume. So the special thing about the volume is that it's measured in decimeters cubed. What is a decimeter? What is decimeter cubed? Well, 1 decimeter cubed is equal to 1 liter. And 1 decimeter cubed is equal to 1,000 centimeters, and 1 decimeter cubed is equal to, centimeters cubed is equal to 0.001 meters cubed. So if you remember these, you'll be able to convert, because in the question they might not give it to you in decimeters cubed, they might give it to you in liters or in centimeters cubed or in meters cubed, and so you have to convert it into decimeters cubed in order to do the question. Now on to the actual question. Okay, so if 20 centimeters cubed of hydrochloric acid of concentration 2 moles per decimeter cubed is required to neutralize 25 centimeters cubed of sodium hydroxide, what is the concentration of sodium hydroxide? So hydrochloric acid is going to be our acid, and sodium hydroxide is going to be our alkali, and it wants us to find the concentration of this alkali. Imagine we did a titration experiment and we found out that 20 centimeters cubed of hydrochloric acid is required to neutralize this volume of sodium hydroxide. So we've done the experiment. Now we do the calculations to find out the concentration of sodium hydroxide. The first thing we do is convert everything into decimeters cubed. So, 20 centimeters cubed. Let's do hydrochloric acid first. So, 20 centimeters cubed is what in decimeters cubed? Well, if we know that 1 decimeter cubed is 1,000 centimeters cubed, then how do we get from centimeters to decimeters cubed? We divide by 1,000. So 20 centimeters cubed divided by 1,000. Remember, this is a calculator exam, you can use your calculator, but you should be able to divide this by 1,000. And that will give you 0.02 decimeters cubed. Now you convert the volume of sodium hydroxide. So 25 centimeters cubed is what? In decimeters cubed, divided by 1,000, you're going to get 0.025 decimeters cubed. Okay, back to the hydrochloric acid, because that's the thing that we know the concentration of. We have to relate the two with moles and ratios. So how do we find the amount of moles in hydrochloric acid? Moles is going to be concentration multiplied by volume. So, what's the concentration of hydrochloric acid? 2 moles per decimeters cubed. Then, you multiply that by the volume in decimeters cubed. We have done that, we've converted it. So 2 multiplied by 0.02 is going to give you 0.04 moles. Now you work out the ratio. To work out the ratio, you need the equation. In the exam, they'll probably give you the equation. It is a neutralization equation. So you have the hydrochloric acid added to the sodium hydroxide is going to give you sodium chloride plus water. This is a neutralization reaction, remember, and in any neutralization reaction, water is produced because the H plus ions and the OH minus ions create the water. So, here is our hydrochloric acid. Here is our sodium hydroxide. We need to find the ratio of hydrochloric acid to sodium hydroxide. To do that, we look at the number in front, not the number like here in the middle, because we're looking at the whole compound, the whole molecule, the whole thing. There is no number here, so we're assuming it's 1. So the ratio is 1 to 1. So 0.04 moles to 0.04 moles. Because it's 1 to 1. 0.4 to 0.4. So therefore, the number of moles of sodium hydroxide is 0.04. Now we have enough information to find the concentration of sodium hydroxide. Let me just rub some of this stuff out, so I have space to write. Okay. So, we know that in decimeters cubed the volume is 0.025. And we just figured out that the ratio is 1 to 1, so it has 0.04 moles. Concentration, how do we work that out? Concentration is moles divided by volume. So, 0.04 moles divided by 0.025 decimeters cubed turns out to be 1.6 moles per decimeter cubed. And that is the concentration of sodium hydroxide. If you don't understand it, I will go and do another question. If you understand it, okay, stop the video or try the next question by yourself. Next question. Okay, if you want, try this question by yourself by pausing the video, and then I'm going to go through it. If you want me to go through it, and obviously I'm going to go through it right now. So, yes. It gives you the equation here. Calcium hydroxide plus nitric acid gives you calcium nitrate plus water. Again, it's a neutralization reaction. It wants you to find the concentration of calcium hydroxide, which is the alkali, if 25 centimeters cubed of 0.5 moles per decimeters cubed of nitric acid, so all this is talking about the nitric acid, is neutralized by 23.6 centimeters cubed of calcium hydroxide. So that's the only information we get of calcium hydroxide, that it's 23.6 centimeters cubed. First thing we do, convert to decimeters cubed. So 1 decimeter cubed is 1000 centimeters. To get from centimeters cubed. To get from centimeters cubed to decimeters cubed, we divide by 1000. So, let's do the nitric acid first. 25 centimeters cubed converted to decimeters cubed, we divide it by 1000. That's going to be 0.025. Okay, decimeters cubed. Then we convert the volume of calcium hydroxide. So 23.6 centimeters cubed into decimeters cubed, divide by 1000. You should get 0.0236 decimeters cubed. Yes. Now, what you do is you work out the moles to relate the two substances. So, to find the moles, you do concentration multiplied by volume. We only have enough information for the nitric acid to do that. So, 0.025 decimeters cubed, which is the volume, multiplied by the concentration, which it gives you, 0.5 moles per decimeters cubed, is going to give you the moles of nitric acid. That's going to be 0.0125 moles. What is the ratio of moles between nitric acid and calcium hydroxide? What we worked out is the number of moles for nitric acid, which is 0.0125. We want to find the ratio of nitric acid to calcium hydroxide. In the equation, oh look, here's a big number. That's 2. And here we're assuming it's 1 because there's no number put there. So the ratio is 2 to 1. Therefore, we divide by 2 to get to this. So 0.0125 divided by 2 is going to give you, standard form, is going to give you 0.00625. And now we have the moles for calcium hydroxide. Let me just go through that again. The ratio is 2 to 1 from nitric acid to calcium hydroxide. 2 to 1, so divide by 2 to get to 1. 0.0125 divided by 2. You will get that. Now, we have enough information for the calcium hydroxide to work out this concentration. Moles over volume. The moles, we just worked it out. 0.00625 divided by the volume, which we converted to decimeters cubed over here, 0.0236, and that's going to give you 0.2648 blah 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 blah. Leave it to 2 decimal places, 0.26. Okay, so we have 20 centimeters cubed of hydrochloric acid, and its concentration is 0.2 moles per decimeter cubed. It neutralizes sodium hydroxide at a volume of 50 centimeters cubed. We need to work out the concentration of sodium hydroxide. Now you probably noticed that most of the questions, in fact all of the questions, are asking you about concentration, and that is actually all they will ask you in your exam. So, here's our equation. Hydrochloric acid plus sodium hydroxide gives you sodium chloride plus water. What do you do first? Convert everything to decimeters cubed. So, 20 centimeters cubed. We know again that 1 decimeter cubed is 1000 centimeters cubed. So, to go from centimeters to decimeters, we divide by 1000. 20 centimeters cubed in decimeters cubed, so divide by 1000, we're going to get 0.02 decimeters cubed. For the sodium hydroxide, 50 centimeters cubed, divide by 1000 is going to give you 0.05 decimeters cubed. Now that you've done that, you need to work out the number of moles in order to relate the two. So, for hydrochloric acid, the number of moles is concentration multiplied by volume. It gives you the concentration, 0.2 moles per decimeter cubed, multiplied by the volume in decimeters cubed. So that's what we've done here, multiplied by 0.02. And that's going to give you 0.004. Yes, moles. And what's the ratio of hydrochloric acid to sodium hydroxide? 1 to 1. So if hydrochloric acid has 0.004 moles, ratio is 1 to 1. Sodium hydroxide also has 0.004 moles. Now I have enough information for sodium hydroxide to calculate its concentration. Concentration is moles over volume. We've calculated the amount of moles. So 0.004 moles divided by the volume, which we have converted to decimeters cubed, 0.05. Is going to give you 0.08 moles per decimeters cubed for the concentration. And now on to the final question, which I will be doing in this video. Okay, so this is our last question. Phosphoric acid reacts with lithium hydroxide, neutralization reaction, to produce lithium phosphate and water. 20 centimeters cubed of lithium hydroxide, that's the volume, of concentration 0.1 moles per decimeter cubed is neutralized by the phosphoric acid with a volume of 8.4 centimeters cubed. We want to find out the concentration of phosphoric acid that neutralizes the lithium hydroxide. First step, convert to decimeters cubed. For the lithium hydroxide, 20 centimeters cubed. How do you make it down to decimeters cubed? Centimeters cubed and decimeters cubed, divide by 1000. You're going to get 0.02 decimeters cubed. Next one, phosphoric acid, 8.4 centimeters cubed. Convert to decimeters, you're going to get 0.0084 decimeters cubed. Now, you find the number of moles using the equation. The only substance we have enough information to do that with is lithium hydroxide. So, to find number of moles, it's concentration multiplied by volume, but in decimeters cubed, which is why we converted it. Yes. So, concentration of lithium hydroxide, 0.1 moles per decimeters cubed, multiplied by the volume, which we know is 0.02 decimeters cubed. And that's going to give you 0.002 moles. Now you find the ratio between lithium hydroxide and phosphoric acid. Use the equation. You have 3, the big number, remember, 3 of the lithium hydroxide to 1 of the phosphoric acid. So the ratio is 3 to 1. And for the lithium hydroxide, we have 0.002 moles. And to make that fit the ratio for phosphoric acid, how do you get from 3 to 1? Divide by 3. So 0.02 divided by 3 to give you the other part of the ratio. Is going to give you, I'm going to leave it as a fraction, 1 over 1,500 moles. That's the number of moles you have for phosphoric acid. And now you have enough information to calculate the concentration of phosphoric acid. Concentration is moles over volume. We just found out the number of moles. 1 over 1,500 divided by the volume in decimeters cubed, which we did convert to 0.0084 decimeters cubed. Put that into your calculator, and that gives you, don't like that number, 0.07936 blah 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 blah. Leave it to two significant figures, 0.079 moles per decimeter cubed. So if you follow these 4 steps, you should have no problem doing a titration calculation. This has been the Awesome Tutor, and bye.